Hi, and welcome back to another episode in the C# Practical Funkiness series. Today we're continuing right where we left off in the previous episode, where we explored the Validatedd T Functor used for validation. But this time we're going to go a bit deeper. We're going to take our humble Functor and level it up into what's known as an applicative Functor. This lets us compare the two approaches to combining validation results. The first one we saw using a combine method, and now the classical functional programming approach uses currying and a single apply method. In our earlier example, the combine method worked, but we would have had to add overloads for each number of parameters that we wanted to support. With the applicative approach, we skip all that. Instead of adding overloads, we rely on currying, breaking a function down so it takes one parameter at a time using a single apply method that takes those parameters one by one and glues them together as it goes. Now I'll be honest, at first glance, currying functions can make your brain hurt. They're a bit of a mental twist if you're used to traditional C#, but once you get the hang of them, you'll realise how powerful and expressive they can be. So what is an applicative functor? A functor, like our Validatedd T, is something you can map over, like applying a function to the value inside the container, as we can do with our map method. But an applicative functor goes one step further. It allows you to take a function that's also inside a container, a validated of Func, and apply it to a value inside another validated of T. Using an applicative functor and its contained curried function, we can then chain apply calls that will allow us to validate each field individually and then build up a final validated result. To compare and contrast this approach with the one that we used previously with our combine method, we're going to reuse the same domain value object fullName. We'll be adding an additional factory method alongside the existing one, but this time we'll build it using the classical functional programming approach with currying and a newly added apply method. Now, not to go over the same old code as before, especially the static rule functions that we built using partial application and our little function factory. This time I thought we'd really go to town on this and make it a bit more dynamic. So this time around we'll imagine a setup where rules are loaded into cache with information for those rules, such as any regex patterns or error messages coming from a database. Why? Well, this opens the door to flexible validation, where rule logic and messaging can be centrally managed and reused across different parts of the domain. Now, instead of wiring up an actual caching library, we'll keep things simple for the demo and just use a concurrent dictionary. It's thread safe, lightweight and perfectly fine for demonstrating the concept. So what are we actually trying to do? Much like last time, the goal remains the same. We want to ensure that the fullName value object is only created in a valid state. We'll use our validated structure for each rule, and as before, we'll aggregate all validation results into a single final validated outcome. Here's where it gets interesting. If you think about it, rules like check that the length is within range or ensure this name follows a certain pattern are reusable. You might apply the same rule to a given name, a surname, a city, and so on. But here's the twist. While the logic of the rule is reusable, the context in which it's applied is not. We still need the field name, like given name or family name, and a display label for the user in order for the error messages to be meaningful. What we want to do is create a rule function using a lambda predicate or a regex, just like before, but this time we'll use partial application in a slightly different way. We will create a partially applied function that still requires the field name and display name, before it can construct a complete validation entry for any invalid value. What this gives us is the ability to request a rule from cache to validate a specific field. The cache method, when given the rule name, field name and display name, can retrieve the rule function, partially apply the field and display name to it, and return a new function that's now customized for that field. This final function only needs the value to be evaluated. Right, let's go through the code required. We'll start with what we've added to our validation extensions class. On line 42, we've added an apply method. This method is an extension on a validated of Func of T-in, T-out. Yes, that's right. The type parameter here is a delegate type. Now here's what's happening. If both the validated with function and the validated item are valid, then the function is pulled out from the validated with function and the value is pulled out from the validated item. The function is then applied to the value, just like any regular function call. The result of that could either be another curried function if there are more parameters still to be applied, or it could be the final output value depending on how deeply the function was curried in the first place. Either way, the result is wrapped up in a new valid validated. If either the validated function or the validated item is invalid, then the failure from both are collected and combined into a new invalid validated that holds all of the relevant validation messages. This whole process can be repeated as many times as needed. Each time you call apply, another layer of the curried function is unwrapped and evaluated until eventually there's nothing left to apply and you're left with the fully constructed and validated result. Let's take a look at the currying part inside the full name value object. On line 49, we define a curried function. It starts by taking a title and returns a function that expects a given name. That in turn returns another function that takes a family name and finally produces a fully constructed full name object. So essentially it's a three-stage function, each stage returning another function until we have all of the values needed to build the object. This entire curried function becomes the type parameter inside a validated, and we wrap the curried function inside a valid instance of validated. From there we chain our apply methods. Each apply call takes a validated input, and if it's valid, feeds the value into the curried function one argument at a time. Each step either progresses the function application if the input is valid, or if it's invalid, it collects and propagates the associated failure messages. Once all three inputs have been successfully applied, we're left with a final validation of full name, or if any validation fails along the way, we end up with a single validated containing all of the accumulated errors. I've placed the rule functions directly inside the apply calls, so they return a validated which plugs straight into the pipeline. All of this is powered by the elegance of curried functions and a single clean apply method. Now let's take a look at the new overloads added to our function factory, the ValidationFunctions static class, which plays a key role in how we build and cache our rules. We've added overloads for both the createRegex rule and the createPredicate rule. Functionally, they're very similar to their original counterparts, but instead of taking a fully constructed validation entry object, they now take the individual components, the field name, display name, and failure message. This change is intentional. By breaking it down into separate parameters, we enable more flexible partial application. For example, we can create a function that knows the pattern or predicate and the failure message and defer supplying the field name and display name until later, ideal for scenarios where you want reusable validation logic but field specific contexts. We've also added an overload of and then, but this one's tailored to our use case, shaped for functions that accept two strings, the field name and display name, returning a function that takes a value and returns a validated. On lines 91 and 92, you'll see we apply the provided field and display names to both functions, which gives us two fully formed rule functions that take in a value and returns a validated. These are now in the exact shape expected by our original and then method, which combines two rule functions into one. So we pass them into that method to produce a composite rule that executes both validations in sequence and merges any validation failures. All in all, this addition keeps our validation logic flexible and modular. Now let's take a look at our simple caching mechanism specifically tailored for our validation rule functions. At the core, we're using a concurrent dictionary to safely store our cached validation functions across threads. The cache item record acts as a lightweight wrapper to store anything since its value is typed as an object. We can store curried functions, fully formed delegates, or anything else we may need. The add or update method is straightforward. It takes a key and a value of any non-null type, wraps the value in a cache item, and inserts or replaces it in the dictionary. We also use a second concurrent dictionary to manage a semaphore slim per cache key, ensuring thread-safe updates even under concurrency pressure. Now the try-get method is where things get interesting. This method takes a cache key, a field name, and a display name. It attempts to retrieve an item from the cache using the key. If the item exists and is one of our expected curried or partially applied functions, specifically a function that takes two strings and returns another function that takes a value of type T and returns a validated result of the same type, then we apply the field and display names right away. This results in the final field-aware validation rule function, a function that takes a value of type T and returns a validated result of type T, which we return via the out parameter. The benefit of this setup is that when this rule is eventually executed, any invalid result it returns will already be wrapped in a validation entry that includes the correct field name and display name, ready to be shown to the user. So this little cache object helps us to keep our validation rules dynamic, reusable, and context aware, all without needing to regenerate them on every use. Now let's take a look at how these rules actually get added to the cache and how they're later retrieved and used. I've added an add rules method as part of the demo code we'll look at and run shortly. The string messages and regex patterns you see in this method could just as easily come from a configuration file, resource file, or a database. That would allow you to rebuild these functions dynamically and update the cache periodically, making your validation system highly adaptable. What we're doing here is using partial application. We define functions that accept two strings, the field name and display name, and return a function that accepts a value and returns a validated result. In other words, we're creating reusable rule factories that aren't tied to any specific field until we decide to apply them. In the case of the family name rule, just like in our earlier demo, we combine two separate rules, one for length and one for starting with a capital letter. We do this using our new and then extension method, which lets us compose these two rule generating functions into a single cohesive rule. Finally, all of these are added to the cache using meaningful keys. Once they're in the cache, they're ready to be pulled out, partially applied with the specific field details and used in validation, making the whole process clean, reusable and contextual. Alright, let's go back to our full name value object. On lines 40, 43 and 46, we use a global key along with a specific field and display name to call into our validation cache. This is where we retrieve the partially applied rule functions we added earlier. Now if there's nothing in the cache for a given key, we throw an exception. and that's intentional. At this point it's a bug if a rule is missing because we can't validate the input without it, and the assumption is that these rules should have been added to cache ahead of time. To keep things as straightforward as possible, which might sound slightly ironic at this point, I've just used constants for the cache keys, but in production setup I'd usually use some kind of mapping layer that might involve using the type name and field name to construct the lookup, helping avoid things like hard-coded strings or accidental mismatches. As already covered, these retrieved functions get executed and return a validated result, which is then passed directly into the apply method that we looked at earlier. And with that, I think we're finally ready to take a look at and run the demo code. Finally, the code inside the run method is pretty much the same as what we saw in the previous episode. The main difference is that this time we first add our rules to the cache and then use the applicative create factory method instead of the regular create method. The end result is still the same. We build up a validated object, but now everything is dynamic and data driven. Let's check that it all works. For the first example, the title passed validation, so no validation entries were returned. The given name used a single rule based on a regular expression. That rule checked both formatting and length in one go. So even though we started with a capital letter, the value didn't meet the length requirement, and as such we got the full message. The family name was a bit different. It used two separate rules, one for length and one for formatting. In this case, the value passed the formatting rule but failed the length check, so we only see that one corresponding failure message. Lastly, we call the applicative create method with a set of good values, and everything passes as expected. And with that, I think we are done. I really encourage you to download the code and walk through it at your own pace. There's a lot going on here, and taking the time to explore each part will help it all come together. I hope you found something of value in this episode. As always, feel free to leave feedback, positive or critical, and I'll do my best to answer any questions you have. If you found this video or the source code helpful, please consider liking and subscribing to help the channel grow. Thanks for watching, and until next time, bye for now.